Hi Emma, how are you doing today? You had a stressful day? Oh, I'm so sorry to hear that, but I am glad that you are doing good now, that you've rested and you are strong now. That means you are ready for class. Oh, that's so good to know. I am Miss Becca, a TLCN certified math educator with over 12 years of teaching experience. And in this demo class, we will be solving exponential and logarithmic equations. Have you heard of exponential and logarithmic equations before? Okay, you don't know what exponential equations are, but you've heard of exponents before. Now, when we have exponential equation, once you know what exponent is and you know what logarithm is, then you will understand what an exponential equation is and what a logarithmic equation is. Let me share my screen with you. So these are our lesson objectives for this class. What are exponential and logarithmic equations? Exponential equations are equations where the variable appear in the exponent. You said you know what exponent is. So when the variable appears in the exponent, that is an exponential equation. Now, this is an example of an exponential equation. When we have 2 raised power x equals 8. This is an exponential equation because the exponent, the variable is in the exponent. So that is what we mean by an exponential equation. Now, the next thing is logarithmic equation. A logarithmic equation is an equation that involves logarithm, usually to solve for a variable inside the logarithm. If we are to solve for a variable that is inside the logarithm, that is a logarithmic equation. And here is an example of a logarithmic equation where we have log x base 2 to be equal to 3. You can see the difference between an exponential equation and a logarithmic equation. This one has the variable in the exponent, that is as the power, and this has logarithm in it. So logarithmic equation, they are the inverse of exponents, and they help in they help us bring down the power. So when we have a power like this and there is no other way out to solve it, we can use log to solve or simplify this. So that is what exponential and logarithmic equations are. Now we will be solving simple exponential equations. Now let's look at this. Let's solve this equation. We want to solve 3 raised power x equals 81. To solve this, the first step we are to take is that we will have to express both sides in the same base. You see that they have different bases. This the base of this is 3, but this is just a whole number. So we have to express both in the same base. And this, you can see that this is a multiple of 3. This can be expressed in such a way that 81 can be expressed in such a way that we have 3 raised power something. So 81 is the same thing as 3 raised power 4, because 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So that means we can write this here. We will use the base that we have on the left hand side. Assuming we have 2 here, then we have to consider if this can be written in base 2. So we have 3 raised power x to be equal to 3 raised power 4. Since they have the same base, then we will equate the exponents such that x will be equal to 4. So we just solve this exponential equation. And if you look at this example that I wrote here also, you will see that 8, we can write 8 in base 2. So this will be 2 raised power x to be equal to 2 raised power 2 times 2 is 4, 4 times 2 is 8. So that's 2 raised power 3. So that means for this one, x equals 3. So now the next thing is that we will be solving exponential equations using logarithm. So now let's solve exponential equations using logarithm. let's use this, see this example. 2 raised power x equals 20. This first method that we did can be used only when this whole number can be expressed as a base of the one that we have on the other side. But for this one now, 2 raised power x equals to 20. 20 cannot be written as a power of 2. So since 20 cannot be written as a power of 2, that is when we have to use logarithm to solve it. Now we have to take the log of both sides so that we have log 2 raised power x to be equal to log 20. We are taking the log of both sides. We are introducing log to both sides. So if log 2 raised power x equals to log 20, now we have to apply the logarithm rule that says log a raised power b is equal to b log a. So we compare that to this now. We are having log a raised power b equals to b log a. So that means log 2 raised power x will be equal to x log 2. And this is equal to the right hand side, which is log 20. Now we divide both sides by log 2. Since we are solving for x, we divide both sides by log 2. Divide both sides by log 2. So that x will be equal to log 20 over log 2. So now we will be using base 10 since that is the general base. So log 20 will now be, when you press it on your calculator or you check the four-figure table, log 20 will be 1.3010, and then log 2 will be 0.3010. Then we will divide, and then x will be equal to, so now we have x to be equal to 4.32. So that is how to solve exponential equations using logarithms. Still on exponential equations, let's look at a more complex example. So let's look at this example. Let's solve this exponential equation. 5 raised power 2x minus 1 equals 625. You know that the first exponential equation we solve is straightforward. The second one, we use logarithm to solve an exponential equation. We use logarithm to solve this exponential equation. And then now we want to solve this exponential equation. The base is 5, and we can express 625 in base 5. So that means we'll be having 5 raised power 2x minus 1 to be equal to 5 raised power 625 is 5 raised power what? 5 raised power 4. Since they are in the same base now, we have 2x minus 1 to be equal to 4, and then 2x will be equal to 5, and then x will be equal to 5 over 2. So that is how to solve exponential equations. Now let's solve logarithmic equations. We want to solve logarithmic equations now. Let's look at this example. Log x base 2 equals 5. This is a logarithmic equation. So what we will do here now is to make both sides look alike. Since we are working in log now, we just have to introduce log to the other side, and it must not affect what we have here. And now log 10 base 10 is 1. Log anything base that thing is 1. Log 2 base 2 is 1. So we introduce log 2 base 2 since we are having base 2 here. So we introduce log 2 base 2 to this other side, so that we will now have log x base 2 to be equal to log 2 base 2, and this 5 now will become the power of 2, such that now that we are having log on both sides, we can cancel out the log. The log on the left hand side, we cancel the log on the right hand side, so that we have x to be equal to 2 raised power 5. And what is 2 raised power 5? 2 times 2 times 2 times 2. So that will be 32. So x equals to 32. That is how to solve logarithmic equations. Now let's solve one more. So we have log x plus 1 base 3 to be equal to 4. We will use the same method. This time around, we'll be introducing log 3 to this side because this is in base 3. So we have log x plus 1 base 3 to be equal to log 3 base 3 power 4. So that x plus 1 will be equal to 3 raised power 4. And then x plus 1 will be equal to 3 raised power 4 is 3 times 3 times 3 times 3. And that's 81. So that x now will be equal to 81 minus 1, and that is 80. So that is how to solve logarithmic equations. So now you are to solve these ones. These are your practice questions. Number 1, 4 raised power x equals 128, and then log x minus 2 base 5 equals 2. So practice those two questions. And what are your key takeaway from this class? Okay, good. That means you've been paying attention. So here is the summary and takeaways. Exponential means variable is in the power. Logarithmic means variable is inside a log, and then you use log rules and conversion tricks when solving. So that will be the end for this class, and I want to say thank you for being active in this class. Once more, I am Miss Becca, the virtual math tutor.